how do we solve it? The idea of finding this yp in here is the following. We are going to say yp is equal to, we are going to set yp is equal to u1 y1 plus u2 y2, right? So here u1 is a function and u2 is a function that we don't know, right? We need to figure out, we need to find out. And the y1 and y2 comes off of your fundamental solution for the homogeneous part, right? FSH, that y1 y2 comes off of, in this case it's a second order, so you're going to have two linearly independent solutions for the homogeneous problem, right? So this y1 and y2 comes from there, and but we don't know how to find the u1 and u2, so we are hoping the yp can be something like this, right? Here we are going, our goal is to figure out your u1 and u2, right? So let's see how do we do that. There is a nice and easier way. By the way, just in case, let me rewrite it again. Here is also u1 is not a constant, by the way, u1 is a function, right? It's a u1 of x, and y1 is also a function, so it's a y1 of x, plus u2 is also a function, so it's a u2 of x, and y2 is also a function, so it's a y2 of x. But from now on, I'm going to write this, for brevity, to keep it simple, I'm going to write it that way. But make sure that these are functions, right? All right. So how do we figure this u1 and u2? So to do that, there is something called Wronskian. We are going to use this Wronskian, right? Or you can say Wronskian method. We're going to use something called Wronskian. So this is, or you can say this is Wronskian method, and that's okay, right? What is this Wronskian business? So this is what we are going to do. The W, I'm going to set a new thing, W. If you recollect your matrix from college algebra, we are going to use the, so this W is some sort of a determinant of a matrix, right? This W is a determinant of a matrix. What do I mean by that? I'll show you in a moment, right? Determinant of a matrix. What is that matrix would be? And that matrix is your first row, right? Your first row is going to be the functions y1 and y2. The second row would be the derivatives of those functions. And this is called the W, right? This is called the Wronskian, by the way. This is what we call the Wronskian, right? So let me give you, what would be your W1? I'm going to call this W1. The W1 is the determinant of a matrix. But now what do? You replace the first column, you replace this first column for the W1, right, by 0 and f of x. And what is this f of x? What is this f of x? This f of x is this right here. That is your f of x, right? And that is your f of x. We are going to keep the second column as is, y2 and the y2 prime. By the same token, I am going to define what is called a W2, which is you keep the first column as is, y1, y1 prime, and you change the second column to replace the second column by 0 and f of x. Right? You first find these three determinants, right? And by the way, this f of x is still that same right here, right? That f of x is still same right there, right? That's not changing at all. All right. Now, what is the, again, my goal is to find the u1 and u2, right? So what do we know is that the u1 prime would be w1 over w, right? And the u2 prime would be u2 prime would be w2 over w. So this is the crucial, right? This is the crucial thing. Once we find the once we find, this u1 prime and u2 prime, then you can integrate, and then from here you can find your, u1, and you can find your u2. Once you do that, once you have the u1 and u2, once you have the u1 and u2, then you multiply y1, then you multiply y2, then you add these two together, and that would be your yp, right? That would be your yp, and that is how we find the yp, right? So that is the idea behind it. Again, this method is not we don't use this method for finding the yc, we use the method for finding the yp, right? So let me give you an example so that kind of, you know, you can easily kind of follow me along. So here I have y double prime plus y is equal to tan x. All right. So let's see how do we do that. So again, this solution, general solution for this particular one, you're going to have solution y equals yc plus yp, right? Make it bigger, yc plus yp, where yc is a solution to the homogeneous problem, right? Homogeneous problem. And this is a particular solution to the non-homogeneous problem, right? That's a particular solution to the non-homogeneous problem. We know that. And again here, let's try to find the yp. So the step one is finding yp. So let me do that. We know how to do that. We first write down the differential equation, the homogeneous version of the differential equation. Then we can use our M&M method. So the characteristic equation here would be m squared plus 1 equal to 0. And then what is MOUC? How do you know when you can use this versus the MOUC? What is MOUC? What is MOUC? Sorry, Dylan? Constants, method of undetermined coefficients. Okay, undetermined coefficients. Okay, method of undetermined coefficients. Okay. So this is the case when where you cannot find this, because the reason is here what you have here is here you have a tan x, right? You can find the annihilator for the tan x, and so therefore you won't be able to use it. Even then, method of undetermined coefficients, you have to guess them, and the guesses are no longer work because of that particular one. Yes, the M&Ms are only for solving the complementary solution, right? Namely the YC, namely for homogeneous version of the original differential equation. So what do we have here? From here, you would agree with me that my m's are going to be plus or minus I. So therefore, fundamental set of the homogeneous problem, in this case, fundamental solution set of this homogeneous problem would be cosine x and sine x, right? So here, my y1, I'm going to say this is my y1, and I'm going to set this as my y2, right? So this is my y1 and this is my y2. Now I'm going to use the now I'm going to use the Wronskian to figure out the yp. So step 2 is to find yp, and that is when we are going to use the Wronskian, right? So variation of parameters. Yeah, so let's do that. So here, let me double check what I'm saying here. My y1, I already set it up, my y1 to be cosine x, and my y2 to be sine x, right? There is nothing wrong in choosing either way. I like this one for various reasons. This works nicely for the Wronskian. You will see in a moment why I like this one. So let's try to figure out these values, right? Now we have our y1, now we have our y2. So now we have our y1 and we have our y2. We're going to plug this back into this. We're going to plug this back into the Wronskian and the w1 and w2, right? We're going to plug all these back in there. But before I go, let me also identify my f of x, right? Let me also identify my f of x in here. So my f of x would be, as you see here, the f of x right here is this guy, right? This is the guy. So in this case, the f of x is exactly the same as that one. So which would be tan x, right? That's my f of x. What is my w1? The w1, as you see here, would be, let me write down just in case for the first problem, y1, y2. These y1, y2s are, again, as I said earlier, coming off of the non-homogeneous version, I mean homogeneous solutions of the homogeneous versions, right? And the second row would be y1 prime, y2 prime. So in this case, if I plug it in, ladies and gentlemen, I am going to have y1 as my cosine x, y2 as my sine x, when I find the derivative, I'm going to have negative sine x. And then when I find the derivative of the sine, I'm going to have cosine x. You all agree with me? Right? Is that's always a 0, Jesse? Yes. In W1, it is always 0. You're always going to start off with the 0 here. Right here, you're always going to start off with a 0. Right here, you're always going to start off with a 0. As a matter of fact, I'll tell you later, even if you have a 3 by 3 matrix, you're going to have a 0, a 0, and then f of x. And then you're going to have a 0, 0, f of x if you have a 3 by 3 matrix. Let's not worry about it for time being. Whenever that comes, you'll worry about it. Right? All right. So let's get back to where we are. Right? Wonderful. Now, what do? I'm going to find the determinant. When I find the determinant, you all agree with me, this would be cosine times cosine x minus sine times the sine x, right? When I do that, that would be cosine square x minus sine square x. The good news is this equals 1, right? The good news is this equals 1, right? It should be W, you're correct. I don't know why I wrote W1, sorry. It should be W. Okay. All right. So the second part is I'm going to figure out the W1, right? W1. Now I'm going to have a 0. And then f of x is tan x. I'm going to multiply that by, what do I have here is sine x and then cosine x, right? When I do that, this is going to be 0 times cosine is 0. And then this is going to be, what you have here is you're going to have sine squared x, or let me write down this way. So sine x tan x, right? And if you really write it, this would be sine squared x over cosine x. And this would be useful for us, by the way, in a moment. That will be useful for us to figure out the integration. All right, let's try to figure out the W2. W2 would be cosine x, sine x, and 0 times tan x, right? And again, if I multiply these two together and then multiply these two together and subtract the later from the former, when I do that, I'm going to have cosine x times tan x minus 0, right? I don't have to worry about it, which then simplifies into simply sine x. The tan x here is sine over cosine, and cosine gets cancelled, right? Cosine and cosine gets cancelled. So what do you have here as cosine x times sine x over cosine x, and cosine gets cancelled. So I'm only left with sine over there. Jesse, are you okay? Why it's not negative sine tan x? Should that be negative sine tan x? You're absolutely correct. That should be negative sine tan x. Yes. All right. Moving on. So we figured out our W. We figured out our W1. We figured out our W2. So right. So we got this and we got that, right? So now you're able to figure out this and this, right? The good news is, in our case, the W is 1, right? In both cases. So therefore, in this case, it does not matter, right? The reason I chose the cosine here and sine here, I chose the y1 as a cosine x and y2 as a sine x. The reason because if I choose the other way, what's going to happen is that this is going to be a negative 1, right? This one is going to be a negative 1, which I don't want that. And then, so you have to deal with the negative in here. You have to keep changing the signs. You have to do a few other things. That's why I chose this way. But again, there's nothing wrong in choosing the other way. You can choose this to be y2 and you can choose this to be y1. You can do either way and that's completely okay. Is everyone okay there? Is everything okay? All right, wonderful. Moving on. Now let's move on. So let's now take a look at the y1 prime. So therefore, your u1 prime, I'm going to borrow it right here, right from here, tells me I have w1 over w, which is negative sine squared x over cosine x, right? Negative sine squared x over cosine x, and the whole thing is divided by 1, which is exactly same as saying negative sine squared x times cosine x, right? And now, so therefore, what is your u1? U1 would be integral of negative integral of sine squared x. This is over, by the way, right? Sine squared x over cosine x dx. You all okay? All right. Now, how do you integrate that one? Right? How do you integrate that one? I'll let you integrate when you're free. Let me give you the answer for that one right away. Right? That integration is a little bit involved. So let me give you the answer for that one right away. The answer for that one is the answer for that one is going to be, I know you're going to, it's going to be sine x minus ln of secant x plus tan x. You have to use some substitution. You know, use the fact you can do some substitution. You can take a cosine to be the u. You can take your cosine to be u, and then the du would be negative sine x cosine x, and then you have a cosine x, and then use the Pythagoras theorem. Sine sine squared x is equal to 1 minus cosine squared x, and then plug it all that in. You will have all that there, right? So I'll let you do that. But anyway, when you do that, the answer that you would get would be the sine x minus ln of secant x plus tan x, right? If you don't know how to do, ask me in the next class. I'll be happy to go through that integration. Okay, so we're now done with that part, right? Now let's try to do the u2. U2, as you see, as per the formula, u2 is going to be w2 over w. The w2 is simply sine x over 1, which gives me my u2. So that's a u2 prime, by the way. U2 would be integral of sine x dx, which is cosine x. Again, you don't have to worry about the plus c part in here. Am I doing okay? Is everything right? Is everything right? Is everything okay? Very good. Good job. Yes, it should not be positive cosine. It should be a negative cosine. Very good. All right. So that's all we have, right? We have our u1 and we have our u2. Let's plug it back into my yp, right? That's all I have. And I plug that back into my yp. What I'm going to have is, therefore, yp, which is, if you remember, u1 y1, yp is u1 y1 plus u2 y2, which in this case would be u1 is what? U1 is sine x minus ln of secant x plus tan x multiplied by y1, which is cosine x, plus u2 y2. I'm going to change the color. Minus cosine x multiplied by sine x. And as you see here, this sine x multiplied with the cosine x is a positive, right? So when I multiply these two together, right, and that will get cancelled, right? That will get cancelled, right, with this one. So the only thing that I'm going to be left with would be negative cosine x times ln of secant x plus tan x. ln of secant x plus tan x, and that's my yp, and that's how we find the yp for this particular problem. So therefore, in this case, the general solution is y equals c1 cosine x plus c2 sine x minus cosine x multiplied by ln of secant x plus tan x. And that's how we solve this particular problem. Any questions for me? All right, so here we found the yc. Now let's try to find the yp, right? Again, the idea of the finding yp is, right, We need to find the yp. We're going to set yp to be u1 times y1 plus u2 times y2, where your u1 is going to be, or u1 prime is going to be w1 over w, and w1 over w, and u2 prime would be w2 over w, where w here w equals y1 y2 y1 prime y2 prime, and w1 equals 0 f of x y1 y1 y2 y2 prime, and w2 equals y1 y1 prime and 0 f of x, right? This example, as a matter of fact, actually in this one you can use the annihilator method, by the way. This example, as a matter of fact, YC is not correct. What did I do wrong? YC, what did I do? Oh yes, you're right, absolutely correct. It should be what? 2 and 2. So it is 2, this is 2, this is 2, this is 2. Man. All right. Right. All right. By the way, it's wonderful. Now let's try to find the u1 and u2 prime, right? Right. So managing too many things. Wonderful. Now what do you have? We have u1 prime is going to be all that, right? But I think before I do that, let me try to figure out the w's first, right? So the w would be e to the 2x, x e to the 2x, and this is 2e to the 2x, and this is x plus 1 e to the 2x. If you do the product rule, that's what you would have. And then you do the determinant, this is going to be x plus 1 e to the 4x minus 2 times x e to the 4x, right? Minus 2 times x e to the 4x. And what would you have? Oh no, I think I made it should be a plus 2, by the way. It should be a plus 2, sorry. Please, those who are not paying attention, please make a note of this change. This should be a plus, this should be a 2, not a 1. I think I had a 1 before, it should be a 2. So is this one, right? So is this one. This should be a 2, this should be a 2, make sure that. Why is that important? That's important because now you see that this, no, hold on, is that a 2? So no, okay, my bad. No, that's not correct. I'm sorry, that is not right. The right answer is, sorry guys. The actual right one's known as 2x plus 1 e to the 2x. And here is also 2x plus 1. Make a note of these changes. Please make a note of these changes, right? If you do the product rule, this is what you're going to have, right? This is 2x plus 1. And the reason is, now you see these two would be cancelled and I will be left with simply e to the 4x. I'll be left with e to the 4x. Let's try to find the w1. W1 should be hopefully easier, not necessarily. W1 would be 0 x plus 1 e to the 2x, and x e to the 2x, and 2x plus 1 e to the 2x. And as you see here, when you do the when you do the determinant, this would be minus x times x plus 1 e to the 2x, right? Yep, that'll be x times x plus 1 e to the 2x. You're all okay there, right? Will the quiz be on this or the reduction of order method? Today's quiz, I think today's quiz is going to be on the homework number 9. W2, right? Let's take a look at the W2. The W2 would be e to the 2x, 2 e to the 2x, and then I'm going to have a 0, and then x plus 1 times e to the 2x, right? This, by the way, those who are wondering where this x plus 1 e to the 2x comes from, it comes from here, right? That's where it comes from. And you know, that's where it comes from, right? Keep that in mind. All right, so now if I simplify this, ladies and gentlemen, what I have here is I'm going to have a e to the 4x, so I'm going to have x plus 1 times e to the 4x minus 0. Just to give me a minute. Excuse the interruptions. All right, so now if I simplify this, ladies and gentlemen, you would agree that this is going to be x plus 1 e to the 4x. I think now we are all ready. This is actually a very simple one. U1 prime is going to be negative, in this case W1 over W, which is negative x times x plus 1 e to the 4x over e to the 4x, which you see that these two gets cancelled. I have negative x squared negative x, right? And we know how to integrate that. If you integrate that, that tells you your u1 would be integral of negative x squared plus x dx, and that's going to give me negative x cubed over 3 negative x squared over 2. Again, don't worry about the plus c, we are going to take care of it already anyway. And then by the same token, if I try to do the u2 prime, which is w2 over, what did I do? That is correct. It's x times x plus 1. That's what I have, correct? Michael, that's what I thought I have. W1 is x times x plus 1 e to the 4x. Did I change it to 2x? Oh, you mean here. Okay, please make a note of that change. Thank you. Thank you. All right, so W2 over W, which is, what do I have here? Which is x plus 1 e to the 4x over e to the 4x, and these two gets cancelled. What I have here is x plus 1. So therefore, your u2 would be integral of x plus 1 dx, which is x squared over 2 plus x. And so therefore, your yp, therefore, your yp therefore your yp would be what would that be? Therefore your yp would be u1, which is negative x cubed over 3 plus x squared over 2 times e to the 2x plus x squared over 2 plus x times x e to the 2x. Is this okay? This should not be okay. I made a mistake purposely this time. Can you tell me where did I goof up? Where did I goof up? Michael, Jesse, Fernando, Andres. We're minus x squared over 2. Very good. Right? So as a matter of fact, I'm not going to change it. I'm going to change it this way. Now it's perfectly all right. All right. Right? So that's my YP. And so therefore your Y is going to be YC, which is C1 e to the 2x plus C2 e to the x times e to the 2x plus, I'm going to copy paste it if you don't mind. Copy and then paste it. And that is going to be your solution to that differential equation. I'm just going to change the color. All right. So that's the solution to the your differential equation. Again, if I did not simplify this. When you're free, you usually say go home and simplify. Now you're already probably at home, so don't worry, you don't have to go home. So after the class, simplify this, right? So you see that there is an x cubed here, and there is also x squared times x over there. There is an x squared over 2, and there's also an x squared over there. So simplify that after the class is done, and that's how we would do this particular problem. All right, so I have 6 more minutes. I am going to quickly solve the next one that you asked me to solve, which is basically how to solve the reduction of order. But before I go any further, is it okay? Are we okay? Any questions? I know I made some couple of goof ups here and there, but is it okay? Can I get a thumbs up or yes? Thank you. Wonderful. We are getting better. I see some thumbs ups. Okay. All right. So you want me to do number 5, correct? Somebody wants me to do number 5. Do you still want me to do number 5? Are you ready for the quiz? Quiz, please. No, Noor wanted number 5. Noor, are you okay with number 5 or you want a quiz? Not Noor. Who wanted number 5? Not Noor. Dylan, I thought. Was it Dylan or Lisa? Okay, Alex. Okay. All right, let's do number 5 quickly. So I'm not going to do the whole thing. I'm only going to do the Y2, but similar idea. Now you have to have the X on the other side for the non-homogeneous problem. Then try to do it, right? So let me try to find the Y2 for that. Okay, wonderful. So the problem is 2x squared y double prime plus xy prime minus y equals x, where x is positive, right? And here, what is given to me here is y1 of x is equal to x. And by the way, I should tell you one thing. Oh, before I forget, I should tell you one thing on the previous problem. That's very, very important. This method, the way that you assign your f of x, right? Is that here it has to be always 1. Here it has to be always 1. If there was a x plus 1 here, right, multiplied, you have to multiply the entire equation by the x plus 1, and whatever you get would be your f of x. You know what I mean? To find the f of x, to identify the f of x, if there is something else in front of your y double prime, you must divide the entire equation, right? We must do the entire equation, and then whatever you're left with on the right hand side should be set as f of x. So for example, let me quickly give an example. If you have a problem that says x squared times y double prime plus x squared y equals x cubed tan x. I'm just making that up, right? But don't just say, oh, this is my f of x. That is not true. What should be your f of x? You have to divide the entire equation by x squared. So you're going to have y double prime plus y equals x times tan x, right? And this is your f of x. When you do this, there is another way to do. I think that is in the book. You can do that if you want to do that way. You can do that, and that one does not. You don't have to do it this way, right? You don't have to do it this way. But if you're using the Wronskian idea, make sure that the coefficient here is always 1 before you find the x. For example, what do I mean? Why do I say that? If you take a look at these if you take a look at this problems in here, right, in here, this is who is that coming online? It's okay, if you have a question you can ask me. See, for example, in here you have x squared plus 1, right? You have x squared plus 1, right? So you cannot say this is the f of x. You have to divide this, you have to divide this side by x squared plus 1, and whatever you get would be your f of x. So in this case, in this particular problem, if you're going to use the Wronskian method, the f of x would be 6x squared plus 1 the whole square, and divided by this right here, which is x squared plus 1, which is going to be 6 times x squared plus 1. That will be your f of x. And for this one, it's going to be the whole thing divided by x squared, right? So make sure that you do that way, otherwise this method is not going to work. All right. Any questions on this? Is it okay? Any questions? Can I get a thumbs up if you have no questions? All right. Thank you. Wonderful. Moving on. So now here y1 of x is given to me. So therefore I'm going to find the y2, where we know that y2 is equal to v times x, right? V times x. And what I'm going to do is, in the interest of time, I have only 15 minutes. Okay. In the interest of time, ladies and gentlemen, let me, I'm not going to do this. I'm not going to write it. I'm going to let me show you the solution, right? So you can kind of see it. So as I said, right? So we are going to set y2 to be vx, right? That's what we are going to set, right? Y2 is equal to vx, and I'm going to plug this back into my differential equation, but not this one, the one with the 0, right? I'm going to set this equal to 0 to find the y2. Remember, y2 is a solution to the homogeneous problem. So to do that, I'm going to do that. So when I do that, what happens? I have to find the y2 double prime, and I have to find the y prime. Then I'm going to plug this back in, right? When I do that, here is my y2 prime, and here is my y2 double prime. If I plug this into a homogeneous version, which is like this, right? If I plug it in, right? If I plug it in, right? That's what I have. When I simplify all that, I'm going to have 2x cubed plus 5x squared, v prime, and v double prime, and so on, right? And then I'm going to do the substitution here. I'm going to do the substitution here. I'm going to say, usually I use the word w, but I think in this one I have a z. I'm going to say let z equals v prime, then z double prime would be z prime would be v double prime. Then you plug it back in, right? Then you plug it back into this. Then you have this differential equation, which you simplify as this. You're going to have it something like that. Here I'm using the variable separable method. Using the variable separable method, I can simply, and then I can integrate it, and then I get my z. Then I set it equal to v prime. From there I get my v. Then you multiply that with the x, and here is what you have, your negative y2, right? And that is how we find the y2. And that's the same idea for finding the yp as well. But here, the yp, you're going to plug it back into the non-homogeneous part, right? You're going to plug this back into the non-homogeneous part, and then do that. The computation is a little bit not bad, right? Computation is not that bad. But here you're going to use, you're not going to use the variable separable. Rather, here you're going to use the integration by parts problem, and that is how you would solve these problems. I hope you're okay, Alex. Thomas, you're okay? I know I did not go through in each and every step. This is okay. If you want to take a picture, you can take a picture, or I don't know, maybe if you're using a screen, you can do a screenshot in this case. Or you can take a picture. Is it okay, everyone? You ready for the quiz? Ready for the quiz? Can I get a thumbs up? 1, not everyone. 2, I have only 2 thumbs up. 3, others. 4, everyone thumbs up, please. Still some people are missing. Fernando, Glenn, Michael, and Andres. All right, so let's do this. All right, thank you. Again, I just don't want to give you a really hard one, so I'm going to do hold on. So we have